Hello everyone, I am Soumya from the Department of Artificial Intelligence and Data Science at SNS College of Engineering. In today's session, we will be discussing one of the core topics in object-oriented software engineering, that is design concept. These are the building blocks for creating well-structured, maintainable and scalable software. Let's begin. Introduction to design concepts. Design concepts are fundamental ideas that help us to shape the structure and behavior of software systems. In object-oriented software engineering, these concepts are used to define how objects are organized and how they behave and how they interact with each other. They guide us in developing the systems that are scalable, maintainable, and reusable, that are qualities that are essential in any modern software application. Then key object-oriented design concepts. There are seven key object-oriented design concepts. First one is abstraction, then encapsulation, modularity, hierarchy, typing, concurrency, and persistent. Each of these plays a specific role in ensuring that software is designed the right way from the start. Let's take a closer look at each of them with examples. Then first one is abstraction. Abstraction is about focusing on what an object does rather than how it does it. It helps to reduce the complexity by hiding the unnecessary implementation details. For example, when you use a car class, you simply call the start engine method without knowing how the ignition mechanism works inside the car. That's hidden logic is an abstraction at work. Then encapsulation. Encapsulation means combining the data and behavior into a single unit, that is a class, and restricting the access to some of the other components. We use the access modifiers like a private, public and protected to control this access. For instance, in a bank account class, the balance might be kept private, while getter and setter methods provide the controlled access to it. These protects the data from unwanted modifications. Then modularity. Modularity is the process of dividing a software system into smaller manageable parts called modules. Each module should handle a specific responsibility and be able to function independently. Take an e-commerce platform as an example. You will typically find separate modules for inventory, payment and user management. Each performs a different function but contributes to the overall system. Then hierarchy. Hierarchy refers to how objects and classes are related, especially through inheritance. It allows us to define a general class and build more specific classes from it. For example, a vehicle, a superclass, can be the parent of car and bike subclasses. This structure supports behavior sharing and code reuse. Then typing. Typing ensures that each object or variable has a defined data type. Strong typing prevents the type errors during compilation. For instance, in Java, you cannot assign an integer value to a string variable. These help us write safer and more reliable code. Then concurrency. Concurrency allows a program to perform multiple operations at the same time. It's especially useful in systems where tasks need to run simultaneously. For example, a chat application must be able to send and receive the messages in real time. That's achieved through concurrency using threads or parallel processes. Then persistence. Persistence is the ability of data to outlive the program that is created it. We usually achieve this through databases, file storage or serialization. A common example is a login system wherever user data is stored in a MySQL database and retrieved when users log in again. Then supporting concepts. In addition to the core design concept, there are supporting ideas that improve the software design. First one is cohesion, keeping the class responsibilities focused. Then coupling, minimizing the dependencies between the classes. Then design for reuse, creating the components that can be reused across different systems or projects. These principles help to ensure that the software is not only functional but also efficient and adaptable. Then, summary. To summarize, the object-oriented design is built on key concepts like abstraction, encapsulation, modularity, and hierarchy. These principles make our code more readable, flexible, and easier to maintain. By applying these concepts effectively, we lay a strong foundation for building robust software system. Thank you for watching this session on design concept in object-oriented software engineering. Thank you.